Hello, and as suggested in the Super Fiendish Sudoku video, we're going to take a look at the dedicated killer Sudoku as well now. See what that's like today. Assuming my computer manages to load it. Come on, come on. Is it going to do it? Yes, there we are. Good. Okay, so as usual, what we should start by doing is writing in things like this. Immediately allows us to do the following on the 7, because 7 can only be made in 3 different ways in 2 cells, i.e. 1, 6, 3, 4, 4, 2, 5, and the 1 and the 3 are already taken by this. So you can actually, the more you do this, the more you practice things like Kukuru as well, the more you can, or the more quickly you're able to just make the very easy deductions that the puzzle's giving you. Okay, there we go. Something I'm noticing immediately is if you look at columns 1 and 2, they're sort of entirely self-contained there. And then if we look at columns 3 and 4, we can actually write in the value of this number. We do a little bit of arithmetic. How can we do that? Well, if we look at columns 3 and 4, we have a number of boxes that are entirely enclosed within columns 3 and 4, except for this cell. And we know that 2 columns in any killer Sudoku must sum to 90, because they're going to contain the numbers 1 to 9 exactly twice. So let's do some arithmetic then. We have 30, 48, 69, 81. So this is a 9. In order that these 2 columns sum to the correct number. And now, does that help? Well, one of the things we can immediately see is that there must be a 9 in one of these cells. And you can very quickly in your mind see that the 9 can't go here, because these 3 cells would then have to add up to 3, which is patently impossible. So there is a 9 in one of these 2 cells, which means there isn't a 9 in either of these 2 cells. Okay. The next thing I'm looking at is this has to be 3, 5, because the 1, 2, 4 here are using up the other possibilities for the way of making 8 in 2 cells. And now we can see this box becomes interesting in terms of where we can place a 9. The 9 has to be up here in one of these 2 positions. And that means that this has to be a 9 and this has to be an 8. And we can almost, this could still just about be an 8, this cell, which is a shame. Because if this was 1 and 2, it would still be possible for these 2 cells to sum to 10, which they have to. And the reason I'm saying these 2 have to sum to 10 is, again, using the 45 rule on column 9, we have 8 plus 11 is 19, plus 16 is 35. So with these 2 cells have to sum to 10. And there's still the possibility of 2, 8 and 4, 6. And even if this was 8 and this was 1 and 2, that would still leave 4, 6 as an open possibility. So we can't quite eliminate down in that way. One thing again, we can use the 1, 3 here, not only on this 7 here, but also on this 8. This 8 can only be 2, 6. So let's put that in. So interestingly now, we've now got a 6 and an 8 in row 1. but we only have 2 open cells here, because these can be neither 6 nor 8. So this cannot be a 7, and this has to be 6 or 8 like this. Which means there has to be a 1 in one of these 2 positions. And the reason I say that is if this is an 8, then this will be 1, 2, like this. And if this is a 6, then this can't be 2, 3, because of this 3. It would have to be 1, 4, like that. Which I think is still possible, yes. So that means we have locked a 1 into one of these 2 positions. It's not going to help us immediately, but we should bear that in mind for later. Okay. And now we can use the 45 rule again on this box this time. We've got 21 here and 14, so that's 35. So we know these 3 cells have to sum to 10. Well, obviously that can't be the case if this is an 8, because both of these cells would then have to be 1. If this was a 7, these would have to be 1, 2, 1, 2. That's just about possible. However, if this is a 6, this would have to be 1, 3, 1, 3, and we've just proved that's impossible. So this cannot be a 6. So in fact, this is a 7, and these 2 cells are 1 and 2 exactly. Now, which in turn means that this is an 8, and this is a 6, which is really nice. So we can then remove 6, 7 possibility here. It means we have an 8 in one of these 2 cells. Might as well mark that, I suppose. Like that. I could use the cursor correctly. Oh, and that means that we have to place a 7 in one of these 2 positions, which means this is a 7 and this is a 9. Which again means that this has to add up to 7, which it can do in a variety of ways actually. So and then we can do some simple arithmetic to tell us a bit more about this column and this 14. We know we need to place an 8 in this column. And it should be clear to everybody that an 8 cannot appear in this 11 box. This 11 box actually has to be a 1, 2, 3 and 5 because it's in 4 cells. And the only way of making 11 in 4 cells is 1, 2, 3 and 5. So the 8 is in one of these 2 positions. And that being the case, the 8 can't go in here. And that means that this has to be 5, 9. In turn, that means there is a 5 in one of these 3 positions, because we have now 5 in 5 here and a 5 here. So however we organise the 5s in rows 4 and 5, they will either be here and here, or here and here exactly. So there's no way another 5 can appear anywhere in rows 4 and 5, and that means that the 5 in this box must be in one of these 3 cells. Simple Sudoku logic, we can lock a 6 in there. I don't think it's going to help us anymore. Think about now there is a sort of bit of advanced logic one could use here. If we imagine a line being drawn across the grid along the line of the cursor as I'm moving now, you should be able to see that only this cell and this cell, these 2 cells, stick out from all of the boxes beneath this imaginary line. Well, what does that tell us? Well, we know that if we add up all the numbers that appear below this imaginary line in the grid, they're going to sum up to 180, because we're going to get 4 lots of the numbers 1 to 9 exactly. And therefore, if we add up all of the boxes that we have given, below this line and this 11 and this 21 box, then the difference between that total sum and 180 will be the sum of these two cells. So let's do that. 142 and 45 is 187. So these two have to add up to 7. That's what my maths is telling me. Now, assuming that's right, and it's very often worth it if you're doing these large sums to double check it unless you're solving at speed, because if you get it wrong you will break the whole puzzle by using the logic. But that being the case, these two cells have to add to 7. Well, clearly if that's the case, this can't be an 8. So the 8 would have to be here. These two cells would have to add to 7. There's still a few ways that that could happen. Let's just think about what else we need in this box. We need a 3, 4 and a... well, we know the 6 is in one of these two positions, so actually it would be like that. Okay. Right, we've now got a very complete picture of column 9 as well, because we worked out these two cells had to sum to 10, so this has to be 4, 6, like that. It's 3, 4, 6. 4, 6, 8 here. It's going to be 5. Okay, so that looks right now. And one thing you could do to make progress from here, I don't know if it's the most elegant thing to do, but if you look at rows 8 and 9, and again we draw our imaginary line across the grid, you've got some fairly big numbers in boxes entirely contained within rows 8 and 9. So let's just see what they sum to. So we've got 26 plus 12 is 38, plus 19 is 57, plus 18 is 75. So that tells us that these 5 cells that I'm highlighting now have to sum to 15. So we know that these two rows have to sum to 90 altogether. So let's ask ourselves whether this could be a 9. If this is a 9, then these 4 cells have to sum up to 6. And it's immediately obvious that that's impossible. Even if we make these as small as we can and make them both 1, 2, then these two would also have to be 1, 2, and therefore this would be 1, 2, this would be 1, 2, and this would be 1, 2, which is impossible. So this cannot be a 9, this has to be a 7, and this has to be a 9. We also know that now that these 4 cells, somewhat surprisingly, have to sum to 8. Well, we can immediately see that if this is a 5, that's impossible. So let's remove the 5 as an option here. And in fact, if this is a 5, it's also impossible, I think, because the minimum this could be is 1 and 2, and you'd still have something to put in this cell, so that's impossible. So we've also isolated the value of the 5 in this 11 now. Okay, so we need to think about, I mean, clearly these two numbers are going to be very small, but it's how small they could possibly be. So it seems like the minimum, if this was a 4, then I guess you could have this being a 1, this being a 2, and this being a 1. That would be just about okay. I don't think anything bigger than that will work. We have something like this as the possibilities here. The interesting thing about that is that a 12 box with 4 cells in it has to contain either a 5 or a 6. Exactly one of a 5 or a 6, because there are two ways that a 12 box can exist in one of these puzzles. It can be 6, 1, 2, 3, or it can be 5, 1, 2, 4. That means that one of these cells is a 5 or a 6. And that's interesting but not helpful enough. If we knew it was a 5, 1, 2, 4 variation, that would force this to be a 5 because of this 5, but we don't, so we can't actually assume that. We've locked 9 into one of these two positions. In fact, should have spotted that earlier. This 2 is forced to be here because of the 2, 5 here. I don't think it's going to make a terribly large amount of difference, but so 4, 7, 8, 9 to place down here. There's a nice bit of logic there as well. So we have to fill in these two cells. We know they sum to 10. It might not be immediately apparent that actually only one of these possibilities is left. So 10 you can make in 4 ways in 2 cells. It can be 1, 9, well that's very obviously ruled out by this. 2, 8 is actually also ruled out here, not by this 8, but by the work we did earlier to prove there was an 8 in one of these two positions. So it can't be down here. So that's impossible. And in fact 4, 6 is impossible as well because of this 4, 6. You can't have 3 4 6s in the same row. So in fact this is 3, 7. You know in what order, but it's definitely 3, 7. It's going to go like that. This can't be a 3. And that opens up another interesting possibility, because this 5 now becomes interesting. Because if we use simple Sudoku rules, the 5 can't go in any of these 3 cells. So the only place it can go is there, in this box. And that forces the 8 upwards to there. And that's interesting too, because it forces a 5 down into one of these two positions. And therefore it has to be here because of this 5 here. And this box now, 26 boxes in 4 are always interesting, especially if you get a couple of numbers in them, because we've got 9 and a 5 in there, and that's 14. So the other two have to be 12, but they can't be 3, 9 or 5, 7 because they're already taken. So the other numbers here are 4 and 8. In some order that we don't know, but there we go. That's, I think, forced like that. In fact, that's interesting too. We've now got a hidden triple down in row 9. We've got 4, 6 here, 4, 6, 8 here, and 4, 8 here. So that allows us to tell this cell has to be 1 or a 2, because every other number is actually taken in row 9. We have a 5 here, so these two have to add to 7, which means that would be 5 or a 6. Well, it can't be a 5, so in fact that's probably going to open the puzzle up to us. This now can't be a 2, and this can't be a 2. Okay. So you'll remember that we'd worked out that these 4 cells here have to sum to 8. Well, now these 3 cells have to sum to 6, and there's a 2 here. So these are 1, 2, and 3. That's absolutely forced, and there's only one 3 in this row that can be the 3, so it's that 3. So that is the arrangement, which means this is a 1, which means this is a 1, and we can remove the 1 here. This can't be a 4 now. And this is a 4. 6, 3, like that. This is a 4. As so often with these puzzles, once you find the, if you like, the point at which they topple, they tend to collapse quite quickly. It's not always easy to find the breaking point. So we've got 2, 3, 7 now to place along here. I think that's looking good. The most obvious way of making immediate progress is to note that we've now got 1 and 2 in the 12 box, so these two cells have to sum to 9. Well, if this was a 6, this would be a 3. That's not possible, so this must be the 4, this must be a 5, therefore this is a 6. So this 11 box now needs to sum to, well, these two cells have to sum to 5, so this is 1, 2 again, which gives us 1 and 2 paired up in the box there. Box of 5 into one of these two positions, well, the 5 could only go here, therefore. These two cells have to sum to 11. And in fact, there's a 7 here. So the only place a 7 can go is here, like this. This is 3 or 4. And this is 8 or 7. Well, this can't be an 8 because of this 8. So this is 7, and this is 4, and this is 3, and this is 2. This is 1, this is 2. This is 1, 6. That. I hope it's, I mean, it should be fairly obvious. I think the puzzle is basically solved now. I simply don't believe there's going to be a difficult logical step that we're going to have to find. So I might do the rest of it to music. But I hope this has been a good watch, and we'll see you again next time on Cracking the Cryptic.